Hello everyone, welcome to this episode of Learning to Research, episode number 5. Today we're going to be discussing recycling single-use plastic. So single-use plastic has been a problem worldwide and it ends up in the ocean. That creates a problem. It ends up in landfill. That creates a problem. Today we're going to discuss on how to manage this waste and how to manage this issue. So for this episode, I'm going to do it much more easily and much more and it's gonna flow better. So what we're gonna do is I'm gonna give you a heads up. Okay, this is how it's gonna go: step 1, step 2, step 3, step 4, step 5, and step 6. We're gonna go through each step. First we're gonna introduce what the problem is. We're gonna go over the overview over here. Right over here we're going to go for an overview, then we're going to talk about introduction to single-use plastic and its hazard, and then we're going to go through prospective solutions to managing the hazards, and then we're going to go through thermomechanical properties of single-use plastic. We're going to dive into understanding what single-use plastic is, into its like chemical and mechanical properties, and then we're going to do a literature review on how single-use plastic has been managed and how that helps us out and which direction we can go, and then we're going to talk about the engineering applications and thermal properties of single use plastic and what we can use, what we can't, what has been done. A little bit on the literature review, we're going to dive that little bit into. We're going to do a little bit of discussion, then we're going to talk about like viable product generation and product study, what product can be made and whatnot. So that's easy. And if you don't have time to look at this video, there's the blog. I've given the link of the blog right below in the description, the blog link, and you can just visit the blog, read through it. The whole thing is over there. Just go over it. It's much more easier if you are much of a person who likes to read than who likes to watch and have me rant. And all the resources that I've used, I've referenced over here, and I'm gonna go through that. Okay, and if you don't like to read, you want me to explain to you how my thought process was, here we are. Okay, so first of all, I'm gonna tell you what big of a problem like single-use plastic is. So earlier I was in this conference organized by Society of Environmental Engineers of Nepal, and then in this conference I presented about entrepreneurship, and they were really like amazed by the fact that you can be an entrepreneur doing new products like this. And they were always, the biggest thing about that whole conference was everybody was scared of trying something new. Okay, so let's say you got a bunch of plastic and you wanted to paste that plastic all over. You wanted to just heat compress it, sell it at insulation pad or a designer pad. They would like hesitant to do that. They would hesitant to even test it. You are engineers, you were open to do that. Not everybody was like that. There were like companies like Doco recyclers and other people who are doing these things, but that was the general trend. And I think because I was talking to a lot of college students, that was the problem. So let's begin. So what is the problem? Okay, let's go a little bit on the overview side. What's the overview? So single-use plastic is a big problem, as you can see from countless different resources and online. You can figure out that single-use plastic is a big issue. Like if you really want to know, just Google single-use plastic and then they'll show you links of animals dying and like impacts in the environment. Like this is just the image of how dirty it looks. Okay, this is how it ends up. Like if you have seen any pan parag or any kind of food packaging, any kind of materials out on the end that looks like plastic or different color, that's single-use plastic. Okay, so look at this. This is a familiar sight to a lot of people in Nepal, right? So that's a problem. But the problem isn't just we're using it. The problem is not that we're using candy wrappers or packaging materials, stuff like that. The problem is that it's not being managed, right? So plastic is sort of a thing that you can take from 0 to 100, right? You can get like those base materials, white stuff, and then you can make it into something good. But the thing about it is plastic doesn't degrade fast, right? So let me just Google this for how long does plastic take to decompose, right? If you just Google this, 1,000 years. There's like a chart like bunch of charts says how long, and this is the life cycle of plastic. And if you don't know, I'll open it in a new tab so that you guys can see it clearly. So a plastic bag takes 20 years, coffee cup takes 30 years, plastic straw 200 years, plastic rings 400 years, plastic bottle 450 years, coffee pots 500 years, plastic cup 450, and on and on. Plastic cup, coffee pots, plastic bags, plastic straw, or plastic rings. At least not plastic bag. These are all disposable, single use plastic. So the idea is to take all of these and then we want to recycle, right? So let's talk about how much hazard it poses, right? Let's talk about the single use plastic. So it's used as packaging, it's used as food material. Yearly 4.8 to 2.7 metric ton of plastic enters the oceans, and that was back in 2010, right? And 300 tons of single use plastic is produced, and only half of that is recycled around. So, and to give a little bit of history, it's been around for more than like 5 or 6 decades. Okay, so it was invented in 1950s, but then it rose to prominence in 1970s. The thing about plastics is single-use plastics is they were invented to counter the use of paper bags that were used, because at that time when these plastics were introduced and they gained a lot of popularity, all the Amazon rainforest was being cleared out and people were protesting. That's why this was an alternative. Now, if you look at it in hindsight, that seems like so back-minded. You could plant trees, but then it's one evil for the other, the devil you know versus the devil you don't. Anyway, so let's talk about what are the few problems that I outlined. Death of marine animals and destruction of habitats for marine animals, right? So if you can see, this all plastic lies down. Like if you look at it, so if you've seen a picture of single-use plastic choking marine life or stuff like that, I'll just Google it for you. That's a problem. Plastic pollution marine life. If you just Google this, so that's a problem. See, and then the other thing, marine animals eat this plastic thinking that's food. It doesn't get decomposed and they like die. That's a huge problem, right? So since that's a problem, that has created such a big impact in the habitat of these planets, animals and marine life, and the planet itself. It's such a bad thing that we haven't done anything to do it, right? Like anything to mitigate it, right? The other is open dumping and like open dumping and open burning of plastic. So have you seen, like, whenever people don't have like a fire starter, they just junk the plastic wrappers or anything, start a fire? That's very harmful to you. If you breathe that smoke, you're gonna die. Okay, this is a problem. Like there's like the big ocean plastic junk. If you look at it, there's like a mountain of plastic over there. Like it's called the Great Ocean Garbage Patch. Yeah, Great Pacific Ocean Garbage Patch. And there's like this giant garbage patch, all for the plastic and all this kind of garbage materials that just it's out in the ocean. Impact in the marine life is. And the other thing is freshwater resources. So similarly, how it lands on the ocean, it lands on the freshwater resource. It's going to clog up the bacterial ecosystem. It's going to cause a problem. The other thing is microplastic can harm human beings, and then it can seep into your food. It can seep into your blood pressure, and then it can seep into your blood, and it's going to create a lot of problem. I didn't say that. This website's saying it right over here. See this? That's what I was talking about. So toxic chemicals that can go into our food and water supply, like I said. So now, what do we do? Like, what stage are we in? Like, how do we move forward? So we're going to think about prospective solutions to managing these hazards, right? What are the prospective solutions to managing these hazards? There's been a lot, The one that I'd like to really mention is the ocean cleanup. What they do is really simple. I'm gonna give you the link for that, and then I'm gonna click a link for the other website. Okay, what they do is really simple. It's gonna sound so dumb. This guy, what he does is gets this boat, and then he has this boat at the end of every river, right? And what they do is they have this kind of a net, and they catch all of this plastic going into that net, and they go into the Pacific garbage patch. They get this kind of interceptor. This is called interceptor. What it does, it is at the end of every river where it meets the ocean, and it sort of acts like a dam or a barrier and starts refining and filtering all the plastic and let the water go out. What it does is it restricts the motion of all the garbage going into the ocean, and what it does is in turn it collects plastic using cutting edge technology to close the source of plastic entering the ocean, and it collects the remaining trash of the ocean. That's very simple. The other ones I'm going to talk about are this is the Good Plastic company that recycles plastic by, you know, creating into like decorative panels and stuff like that. What they do is they cut these plastic materials, and they create insulation panels. They don't have a lot of information, but what they do is they just use extrusion compounding, or they use injection molding to do that. It's very easy. And if you want to learn about what injection molding is, all you have to do is Google. There's this really nice website called injection molding. This is what happens, guys, if you leave your YouTube on injection molding. This is what happens. And there's this guy, I forgot his YouTube channel. If you type in plastic YouTube channel, if you do that, wow, it's gonna get blocked. There's this guy from Sweden. I think he's Swedish. There's this Swedish guy who runs this YouTube channel called like Plastic. He has wonderful ideas of recycling plastic. Okay, so the other idea is chemical recycling. What they do is it's pretty simple. They use plastic polymers, they break down the chemical, and they turn it into fuel. Ultimately, if you use fossil-based fuels, it's very hard. And the one more thing, plastic is made out of fossil fuels, so you can turn it into fuel and then use it, but it's still not going to take out the carbon from the air and the pollution it causes. The other one is, this I really like. So what they do is, so time and time again, I've heard from environmental engineers that you can't combine plastic, you can't combine plastic. Let's say you combine it, and then you make an inferior product that's not typically the same product, but then you can make a completely different kind of product. That's what New Tech Poly does. And what they do is they combine different sort of plastic, blend it to make different kind of products, and those products are originally not the same. So let's say if you had like a box, like a plastic cover case for a phone, right over here, it would not make the same plastic cover case phone, but it would make something else, like, you know, like a construction material or something like that. Okay, now that we covered the prospective solutions to managing the hazard, that's how like the folks over there in the startup industry are doing abroad and everywhere else. What can be done? We're going to cover a little bit more on this on the literature review and engineering application and viable product generation. Let's talk about the thermal properties and mechanical properties of single-use plastic. And before that, we need to understand the chemical composition of plastic. So if you Google plastic, right, and what comes up on Wikipedia is all these kinds of formulas and everything, all this page. But then if you really look at this one single chart over here, They give you different kinds of plastic. But then the ones that I'm interested in, bottles, caps, drinking straws, all these, they're single-use plastic. And the other types of plastic that they use are non-single-use plastic, except for peanut butter. I don't think peanut butter jar is single use, but then polystyrene is sometimes single wear plastic too. So polypropylene and polystyrene, these are single use plastic. So that's what I figured, and this is the chemical formula, chemical composition for polypropylene, and this 6 is just the resource that I used to get that. So polypropylene, they are heat resistant and insulating. They have a high amount of tensile strength, which means it can stretch. As you can notice, they're really rigid, but they have their own limitations as well. They're excellent candidates for single use. So this is a plasticizer. A plasticizer is something that can be added to your base plastic or base product, so that you can create different kinds of coloring, or you can make it whatever you want. The variation in amount of plasticizer or kind of plasticizer makes the difference on the kind of product you want to make. Depends on product by product basis. If you want to learn more, just go ask to an industrial engineer, they'll tell you. So let me talk a little bit about polypropylene. That means it has a density of 0.895 to 0.92. That means water has density of 1 gram per centimeter cube. If you don't know what density is, I don't know why you're here. And that means it can float on water. That's why we have a Great Pacific Garbage Patch, because if you weren't floating on water, it would just sink, and we'll all be solving, not having that problem right now. The other thing about it is the density of seawater is a little bit higher because of the presence of all the salts in the water and all the minerals in the water, and because of that, it's going to cause you a lot of problems. And we're talking about polypropylene, it has a 171 degrees Celsius melting point. That means it is very, very resistant to heat, but it is not fire retardant. Okay, it is fuel. If you burn it longer, it's gonna burn up. Don't use it in a house to like in higher temperatures. That's just what I'm saying, because plastic warps and melts. It has to be heat resistant. It has to be a thermoplastic. If you don't know what a thermoplastic is, just Google thermoplastic. These are used in thermoplastics are used in like different cases where you need high heat. And good thing about plastic is, or bad thing if you leave it out in the open. The good thing is, if you're intending it for a purpose, it's not degrading unless you put it on bleach. Have you watched that Breaking Bad scene? Breaking Bad, plastic melts. So using hydrofluoric acid, remember that episode? I think that episode where they put where Jesse, instead of using ceramic to do that, spoiler alert, he puts hydrofluoric acid and just puts it on plastic, and that eats through the whole floor and everything. Yeah, if you use strong oxidants, that's what's gonna happen. So yeah, that's it. So let's move on into the other steps. Step 4, literature review. Literature review, we're not gonna talk a lot. We're just gonna talk about something here. The first thing we're gonna talk about is how plastic has been used in the construction industry. It has been used to create tensile reinforcement of cementitious mortars. And on little about, like, as much as I know about civil engineering, I know very little because I'm a mechanical engineer. Cement and concrete is really good for compression. Yeah, compression, not for tension. Okay, so when you have something that when you have a structure, you want to make sure, as a structural engineer, it bears a certain amount of tension and compression. So if compression is high and you want tension, you want to make a composite material. For that, this research, what they're proposing is they're using recycled nylon fibers, which are also single-use plastic in some cases, and they're using it to reinforcement. Now, I'm going to give you a better example close to home in Nepal, where they've used single-use plastic to create black pitch road. I'm going to read it to you verbatim. Youth in Pokhara have shown way to recycling plastic by paving a section of road with non-biodegradable waste. Picture order out. Plastic wrappers from noodles, biscuits, meal packets, and tobacco were used. So these folks just used plastic wrappers from all this, melted it down, and used it to make black pitch roads. Right? If you use other kind of materials, hard. Green road management introduced plastic. Basically what I'm talking about. That's the literature review over here. I talk about this in depth over here. You can read it, and then I'm gonna explain to you what this figure is. Okay, this is the life cycle assessment of waste curation. If you look at the first part of this picture, right, you have the environment and you have this. So your energy comes in, raw energy comes in, industrial society, all this thing is being used in our societal system, plastic wrappers and everything goes thrown into the landfill. Somehow it makes the microplastic reach up in the air, somehow they reach up in the water, and somehow they reach up in the soil. It creates all these degradations I was talking about earlier on right here. So microplastic can cause human impact, and then they can cause all these problems. Agriculture is impacted and everything else. So all these problems are created, right? That's just the waste creation side. Let's go a step further. Waste prevention. Instead of sending into landfill, why don't we prevent the use of plastic a little bit? We curtail it. What it does is it creates less emission here, right? We go a step further. Integrated waste management. What we do is, instead of sending directly to IWM or integrated waste management, what we do is we employ the solutions that we talked about earlier, and then we create a circular economy. And instead of making it, throwing into landfill, it turns into energy or turns into raw materials and keeps feeding itself and creates a circular economy. What it creates is new job opportunities and all of that. Now we know this, right? We're armed with this knowledge. Let's see. Let's choose specific properties of single-use plastic, and we can come up with something like some new product, right? Let's go into that. That is step 5. We did a little bit of literature review, a lot, and then we approached here. Engineering, application, and thermal properties. So here, right? So the thing about it is most single-use plastic are they rely 150 degree above. They're heat resistant, but they are not fire resistant, but they are insulating. That means they have a certain amount of insulation properties, and if you can hollow them out, if you can make composite materials, they can be created into sound insulation. If you look at fiberglass, it is plastic. It is great for insulation, right? But it's very dangerous too. So microfiberglass, if you inject it, it goes into hand, it's going to cause a lot of problems. So, and one more thing. I'm going to read out to you. Mixtures of polymers can be produced economically without sophisticated sorting to produce low value products. Where did I get this? Okay. I'm going to explain to you where I got this. Okay. So I was thinking in my mind, if I know the thermal properties, maybe I can use the thermal property, leverage it and make a new product. For that, I searched thermal insulation. What are the different kind of research? So maybe I don't want to sort it, right? I don't have the money to sort it. I want to make it cost effective. So instead of sorting all the plastic, single-use plastic, what I do is I jumble it all together and I melt it and I create this new product, right? Is it feasible? What this research says here in the conclusion is it is feasible. They did a lot of testing with different kinds of plastic, ABS models, single-use plastic, everything else, and they came up with this conclusion right here. Mixture of polymers can be produced. That means you can mix and then you can make it economically, but it might not be the same product as you started. Let's say if you wanted to do, if you want to break this phone down and then break this laptop down right over here and then mix it with a lot of wrappers and candy wrapper, it's not going to give you the same amount of tensile strength as the, or the structure as the laptop, but it won't give you the worst condition of the wrapper if you wanted to make something like solid, right? So it will give you the best of both worlds and the worst of both worlds. So, and then they have a lot of things, and then I'm gonna tell you a little bit about this, why I'm so worried about like heating up and doing this. It creates a lot of odor and burning, and you have to use a lot of fuel to do that. We don't want to do that. So we go into the next phase of our research, which is viable product generation and product study, right? And let me summarize what we've done so far. Okay, we know we can deduce the following. Recycling plastic meets the needs of consumers and environment. There is a need for that, right? Good. When you have a need, you can create a product. Viable product solution can be created from mixing and using multi type of plastic, which we just established. Cost effective solutions are feasible. You can make new product. It is really cost effective. And the best part, raw materials are available. They're dirt cheap, or they will even get to your house. And thermodynamically, it is a very good material for insulator. So now we know this, right? Is an abundance. Everything is good. So what are the possible viable products? You can make insulation panels, right? Based on all that we know. You can make art or paint materials, because if you can use it to add color, if you can use it to add mixtures, you can make it into art and oil paints. Clothes can be made from fibers. You can use it to turn into fibers, and you can make it into clothes. If you remember back in Brazil, when they made, or it was it in the one of the World Cups, they made all the jerseys from PET bottles. They use fibers from those, so recycled fiber. You can make composite clay materials, right? Plastic composite clay. These are great for sound insulation. So you can make plastic composite clays. This is really good. These are awesome. These are really good. And China has a lot of that. You go research it, Google it, and do all of that stuff. Insulation packets. So insulation packets. So you can make these insulation packets, small packets of insulation, like bags, stuff like that. You can make that from recycled paper. Insulation panels and insulation packets are different. You can make packaging materials from recycled plastic. So just Google this. And boom, you have it. There's even value chain like study and how much production and all of this is given, right? So do all of this, choose the type of plastic. Okay, so plastics have these codes. Choose, learn a lot, and then you can leverage all of this into like making into a viable business. And that's it for today. And if you want to learn more, just go into the series, just watch more videos. If I've uploaded new videos from episode, like after episode 5, just watch those. If I've uploaded previous videos, go watch those. But keep learning, keep researching. And when you research and you're trying to solve problems, like if all of us add our small efforts, it's going to create this giant impact that can, actually help the planet and stuff like that. So today, say goodbye. I hope to see you in future episodes. Bye bye.